Hello and welcome to the Chandara Academy. Sumsakan Makan Chandara Academy. In today's video, we are going to calculate the following limits. The first limit, A, would be the limit when x tends to 2 of this whole thing. If you do the calculation when x tends to 2, 2 minus x will tend to 0, and x squared minus 3x plus 2 will tend to 0 as well. And so we will have an undefined form 0 over 0. We call them undefined form. Same thing here in x tends to 1. For this expression here, we will have an undefined form 0 over 0. Let's work to not get undefined form anymore. Let's start with the first one. So for all x in, let's call this one f of x, okay? For all x in df, so when there are no problems, what do we have? We have 2 minus x over x squared minus 3x plus 2. That will be equal to what? We want to make appear at the top and at the bottom some x minus 2. Why x minus 2? Because x minus this value. Because we know that the polynomials cancels in 2. So, of course, there is a factor x minus 2, so we want to make it appear at the top and at the bottom. Very easy at the top because we have easily at the top minus x minus 2. Now what about at the bottom? At the bottom, x squared minus 3x plus 2 is equal to x minus 2 times what? Times some second degree polynomial ax plus b, and we want to determine a and b. How do we do that? We see that in front of the x squared, we have a 1. And how can we create the x squared? Just by multiplying ax times x. This is the only way to do it. And so we know that a is equal to 1. Almost same thing for b. We know that the 2 can only be created by minus 2 times b. And so we get that b is equal to minus 1. So 1x minus 1. And now we know that df is for all x not, so for all x not in 1, 2. These are the two forbidden values. And we can say that this thing here is equal to x minus 2 times x minus 1. And this is now easy to simplify. Simplify the x minus 2 together to get minus 1 over x minus 1. And this thing is very easy to compute when x tends to 2, because this will be equal to minus 1 times 2 minus 1 over 2 minus 1. And this is minus 1 over 1, and we get minus 1. Our first limit, a, is equal to minus 1. Now, second limit. We will have kind of the same thing. We will want to make appear some x minus 1. Why x minus 1? Because our function, let's say, our limit goes, and we have a problem in x is equal to minus 1. Here we have a x minus 1 already. We want to make 1 appear here. How do we do that? We want to get rid of this square root. And for that, this is kind of always the same method when we get to some fixed limit. We will use the identity a squared minus b squared is equal to a minus b times a plus b. And here we can identify a minus b, because now we will have a squared, which will be 4, and minus b squared, minus this whole thing squared. And so we will get rid of the square root. How do we do that? So for all x different from 1, we got 2 minus square root of 3x plus 1 over x minus 1. We have just to multiply by the complement to 2 minus square root of 3x plus 1, which is 2 plus, this time, square root of 3x plus 1 over the same thing, because we want to multiply by 1 to not change the equation. Okay, now we develop. This thing is equal to what? To 4, which is equal to 2 squared, minus 3x plus 1. The minus goes through all the parentheses over x minus 1 still times 2 plus square root of 3x plus 1. This will not cause any problem because this thing will have a limit, okay? A limit, okay, so a value in x tends to 1. So we can keep it like that. Now let's simplify the top of the equation. We have this thing that's equal to 4 minus 3x minus 1. Perfect. Which is equal to minus 3x plus 3, which is equal to minus 3 times x minus 1. And now we can easily simplify the x minus 1 at the top with the x minus 1 at the bottom. And we have minus 3 over 2 plus square root of 3x plus 1. And this thing has an easy limit. When x tends to 1, this will be equal to minus, this will tend to minus 3 over 2 plus square root of 3 times 1 plus 1, which is square root of 4, which is equal to 2, and we will have minus 3/4. B, which is our limit, would be exactly equal to minus 3 over 4. And we have solved our exercise. I hope you enjoyed the video. See you soon. Bye.